Okay, so in this video I'm going to be covering exercise 9A of the EDEXCEL A-Level Maths book for year 2. Just to mention quickly that there's not actually going to be any teaching done in this video. I'm just going to be going through the questions and how I would approach this question and the questions after this, and kind of my thought process and how you should think about answering questions like this as well. Okay, so let's start with question 8. Okay, so question 8 says that a curve has the equation y equals sine 5x cos 3x. Find the equation of the tangent to the curve at the point pi minus 1. So the key thing is finding the equation of the tangent and not the normal. Okay, so let's write down the important information. And we're given a point, let's call it p pi minus 1. Okay. So this is a differentiation question, so we will have to differentiate. So let's think about differentiating this curve. Okay, you know that if you're given something in the form sine of kx, the derivative of that is k cos kx, where k can be some number. Okay, so for example, think about 2, 3, 4. K can take on any number, and so the derivative will be k cos kx. So this means that if I have sine 5x, then the derivative of that is 5 cos 5x. Similarly for cos, if you're given y equals cos kx, the derivative of that would be minus k sine kx. So then in our case, we wouldn't have a plus here, we would have a minus 3 sine 3x. Okay, so now that we've differentiated it, we need to find the equation of the tangent to the curve at the point pi minus 1. So before we find the equation of the tangent, we need to find the gradient of the curve at this point. And how would we find the gradient of the curve? Well, we just substitute our x-coordinate, which is pi, into our differentiated equation. So let's consider dy by dx at x equals pi. What do we get? Well, we get 5 cos of 5 pi minus 3 sine 3 pi. And you can put these values in your calculator, and you could notice that what you get is dy by dx equals minus 5, because this goes to 0 and cos of 5 pi is minus 1. So what you're left with is minus 5. Okay, so now that we found the equation, we found the gradient of the curve at the point p minus 1, what we can do is we can start finding the equation of the tangent. So we have been given two things. Okay, we've been given the point, which is pi minus 1, and what we found is the gradient, m equals minus 5. Okay, so there's a couple ways you can do this. I'm going to use the y equals mx plus c method in this question, and in the question after that I'll be using the y minus y1 equals mx minus x1 method. Okay, so for this method, what do we have? Okay, well, let's substitute in the y coordinate of this point. So we have minus 1 equals m, which is the gradient of the line. Again, remember the gradient is m and c is the y-intercept, which we need to find. So substituting in the gradient, you get minus 5. The x coordinate of this point is pi and plus c. Okay, so rearranging for c, you get c is 5 pi minus 1, and so the equation of the tangent is y equals mx plus c, and we've already found c, and we know that the gradient is minus 5, so we have this equation for the tangent to the curve at the point p pi minus 1. Okay, so let's have a look at question 9. A curve has the equation y equals 2x squared minus sine x. Show that the equation of the normal to the curve at the point with the x-coordinate pi is this. Okay, so it's quite similar to the last question, except this time we have to find the equation of the normal. Okay, so let's have a look at how we would do something like this. Again, let me switch back to black. So we're given y equals 2x squared minus sine x. We're given some information. We're given that this time we're not given a point, actually, we're only given an x coordinate. Okay, so let's have a look at how we do something like this. Again, this is a differentiation question, so let's start with that. 4x minus cos x. I'm not going to be teaching you how to differentiate. This is just a video on how to approach questions like this. Okay, so we found that the derivative is 4x minus cos x. And a good next step would be to find the gradient of the curve at this point. So let's do that. How would we do something like that? Well, we substitute in this x coordinate, x equals pi, into our derivative. Okay, so we get dy by dx equals 4 times pi minus cos of pi. Okay, and we get 4 pi minus 1 because cos of pi is minus 1. So our gradient is 4 pi plus 1. So what we found that at the x coordinate pi, the gradient of this curve y equals 2x squared minus sine x is 4 pi plus 1. Okay, but the question is asking us to find the equation of the normal to the curve. Okay, well, if we were to find the equation of the tangent to the curve, we know that the tangent to the curve would have the same gradient as the curve at that point, but the normal to the curve would have a negative reciprocal as the gradient. Okay, so let's have a think about what the gradient would be of the normal. M would be the negative reciprocal of this, which is minus 1 over 4 pi plus 1. Okay, so we are almost there. We just need to fill in the y coordinate, because to find the equation of a line, we need the gradient and we need a point. Now we're given half of a point, so how would we go about finding the y coordinate at this point? Well, we take the x value which we've been given and substitute it into the equation of the curve. Okay, so how would we do that? Well, y equals 2 times pi squared minus sine of pi. Okay, and sine of pi is 0, so all we're left with is y equals 2 pi squared. Okay, so now we have everything we need to find the equation of the normal to the curve at the point where x coordinate is pi. So, like I said, in this question I'll be using the y minus y1 method to find the equation of a line. Okay, so y1 and x1 are the coordinates of the point which the line passes through. So we know that the line must pass through this point, so we can replace it with y1 would be the y coordinate, so 2 pi squared equals m, and we'll fill in m in a second, minus x1, which is the x coordinate, which is pi. Okay, and kind of making space for m. M is what we have found here. Okay, x minus the x coordinate pi. Okay, so now all we need to do is rearrange in the desired form. Okay, so they want it in the form ax plus by plus c equals 0. Okay, so let's do that. Let's first expand the right hand side. So we have y minus 2 pi squared equals, expanding the right hand side, we have minus 1 over 4 pi plus 1 times x. So that gives us minus x over 4 pi plus 1. And then we have minus 1 over 4 pi plus 1 times minus pi. So what we have is over pi plus 4 pi plus 1. Okay, so now let's rearrange. So I'm going to bring the x over, plus y minus 2 pi squared, and then I'm going to also bring this over. So on the right hand side, all I'll have is equals to 0. So this entire thing equals 0. Okay, now I'm going to multiply everything by 4 pi plus 1 because I know I need x by itself. Okay, so let's do that. I have x plus 4 pi plus 1 times y minus 2 pi squared times 4 pi plus 1. And then this is already being divided by 4 pi plus 1, so if I multiply it by 4 pi plus 1, this will cancel and all I'll have is minus pi. Okay, and now we're almost there. We just need to rearrange a little. So okay, expanding this, I get minus 8 pi cubed minus 2 pi squared. So that's this expanded. and then minus pi equals 0. Okay, so then 4 pi plus 1, I'm almost there. Y, and then from this 3 terms, what I'm going to do is I'm going to factorize out minus pi, and what I'll be left with is 8 pi squared plus 2 pi plus 1 equals 0. And this is the equation of the normal to the curve at the point where the x-coordinate is pi. Okay, so let's have a look at question 10. Prove from first principles that the derivative of sine x is cos x. You may assume the formula for sine of a plus b, and that as h tends to 0, sine h over h tends to 1, and cos h minus 1 over h tends to 0. Okay, so in a question like this, the first step would be let f of x equal sine x. Okay, and you should already know the formula for a derivative. F dash of x is limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, so let's replace the f of x plus h with something. If we know that f of x is sine x, and I'm going to write the x in brackets just to make it clear, then f of x plus h must be sine of x plus h. Why is that? Well, because wherever you see an x, we have that f of x is sine x, so we've replaced the x with x plus h, so that means in our function sine x, wherever we see an x, we must replace with x plus h. Okay, so let's replace the numerator with that. We have limit as h tends to 0 of sine of x plus h minus f of x, and we already know that f of x is sine x all over h. Okay, and now, well, it's not immediately obvious what to do, but we can look at the question. You may assume the formula for sine of a plus b. This is the hint they've given us. Okay, so the formula for sine of a plus b is sine a cos b plus cos a sine b. Okay, and in our case we don't have sine of a plus b, but we have sine of x plus h. So if I write this underneath, it should be clear how we can adapt this formula sine of a plus b to our situation. So we have sine x cos h plus cos x sine h. So wherever we see an a in this formula, we replace with x, and wherever we see a b, we replace with a h. Okay, so let's now incorporate that. So we replace sine of x plus h with this. So sine x cos h plus cos x sine h minus sine x all over h. Again, now it's not immediately obvious what to do, but we can again look at the question and see the information they've given us. They've told us that as h tends to 0, this tends to 1, and this tends to 0. So let's now maybe factorize or split this quantity up into this, and then we can then simplify. So we have limit as h tends to 0, and what I'm going to do actually is I'm going to group all of the sine terms into one fraction and all of the cos terms into one fraction. So more specifically, all of the sine x terms into one fraction. So everything that contains a sine x, so this and this, I'm going to split into one fraction, and everything that contains a cos x, which is this, so let me do that in a different color. Everything that contains a cos x, I'm going to split into another fraction. Okay, so what would that look like? I have sine x cos h minus sine x over h, and then plus cos x sine h all over h. Okay, and now I can factorize the top. So I have limit as h tends to 0 of sine x cos h minus 1 all over h, and then again I can factorize out the cos x all over h. Okay, and now the next step would be to distribute the denominator of h into the brackets of each fraction. So sine x times cos h minus 1 over h plus cos x sine of h over h. Okay, now I've got it in the form which they wanted. Okay, and I can now take the limit. So the limit as h tends to 0, we know that this term they've told us tends to 0. and we know that as h tends to 0, they've told us that this term tends to 1. So then I have sine x times 0 plus cos x times 1, and so the final answer, f dash of x, is cos x. And you've proved from first principles that the derivative of sine x is cos x.